especially finding aircraft. In fact, radar was directed to locate the aircrafts during the Second World War. Okay, so radar is a short form of radio detection and ranging. That is the full this one. Short form is called radar. Okay, why it is called radio detection? It uses electromagnetic wave or radio waves. It uses radio waves or the electromagnetic wave for detecting the objects. Okay, so that's why it is called as radio detection. It sends radar electromagnetic waves. It what do you call it? Propagates or transmits. Definitely, right word is called transmitting. We are going to see it. It transmits radio waves using an antenna. Okay, that is transmitted by this one, and when it propagates, it travels in the space. Okay, then if it hits an object, if object reflects, if these radio waves are reflected like a light, correct? If you put a mirror, light will be reflected. Similarly, radio waves can be reflected by objects, but some objects or some material will not reflect inside, they just absorb. In periodic table, you have more than 100 different elements, correct? Starting even hydrogen, helium, iron, copper, nickel, correct? Uranium, all those things, gases. Some elements, we call elements is this one, can absorb the light, these radar waves or electromagnetic waves. If I coat my object with those material, it cannot be detected by radar also. Correct? That's what called a stealth fighter plane. For example, America is saying F-22 plane. Correct? It says that it cannot. B-2 bomber. Correct? These two fighter planes are very popular in military circles around the world. It is the first one is a bomber, which was in U.S. Air Force for last 20 years. And if it is flying, they are big objects. The length, width, and there is a B bomber maybe to 120 meters wing span. Correct? The length tip to tip. This may be 80 meters, 100 meters. Such a big, it will be generally like this. It will be something like this. They call flying wing. The shape of this one will be like B-2 bomber. This length is around 160 meter, 130 meter. These legs are 90 to 100 meter. Exact, I don't know. This object flying in the sky cannot be detected by radars. Why? They coated the body of this aircraft with electromagnetic absorbing material, radar wave absorbing material. There are few materials in here. Those material very expensive, right? That is not our interest. But most of the elements, or metals, all these things can reflect this material. This one, electromagnetic waves. The electromagnetic waves sent by the radar, and it travels in the space. For example, I have a radar. This is my radar. Correct? This is my antenna of the radar. Say as a dish and a parabolic reflector, it transmits radiomagnetic wave. Okay, this is traveling. EM waves or radio waves is transmitted by the antenna of this one. This is my radar system, right? And it goes and hits the flight. Okay, and this is my aircraft, and the aircraft may be coming towards you. And if the light is this one, it will be reflected, right? Most of the elements will reflect electromagnetic waves. And if it comes and hits the antenna again, that will be picked by the antenna, that will be processed by, due to reflected signal, the radar can detect objects. Right? This is how the radar works. What it does, it transmits radio waves, and if the wave goes and hits a target like a plane, if plane reflects the radio wave, the reflected wave is shown blue color, it is coming towards this one, and again it hits the antenna, it generates an electrical signal. That signal again be received by the radar electronics, and using that, it can say that whether object. If there's no object, what will happen? The radar wave will just go in the vanish. It traveled for some distance. After that, the electromagnetic waves will be absorbed by the atmosphere or air molecule, gas molecule, dust molecules. Finally, just simply vanish. Energy is lost. So this is how radar works. Okay. So we'll see that. So it uses a electromagnetic wave. Now you are transmitting electromagnetic wave. Generally, it has to send a sinusoidal. Most of the time, it be a sinusoidal wave or pulses. It can be sinusoidal electromagnetic waves, or it can be square pulses. Okay, so this is transmitted by the this one. Now, when we know that x-axis we are transmitting the electromagnetic waves, it goes, for example, this is a transmitted wave, and it went and hit an object, and this is called reflected wave, received wave. I sent a square pulse, right? Square electromagnetic wave, and this was traveling. Okay, and it went and hit an object, and this is reflected. Now we know that at what time, this is time t equals 0. At time t equals 0, it sends a small electromagnetic square type pulses, and it traveled in the space, taking some time, exact time. After that, it hits an object, and the reflector received. So the total time, for example, after 10 microseconds, right? I transmit t equals 0 microsecond. After 10 microsecond, this is total time the antenna received. Correct? The total time equal to 10 microseconds for this wave to travel and again reflected back to antenna. Now I divide this time by 2. Why? Because the same when traveled this much distance using total time in 10, the time taken for just one-way travel, how much? Divided by 2. Correct? 10 divided by 2. That means 5 micro. One-way travel is 5 microseconds. My interest is to find out where this object is. This is my radar at transmit t equal this one, and it went and hit and come back. I want to find what is distance, measuring distance, that is deducting and finding the object. We see that radio deduction and ranging. Ranging means measuring the distance. In radar terminology, ranging means, we know the range means generally distance. Another word for range. In English, you can range. What is the range it went? What is your range? Home range, or how got this sort? So range means distance. So first thing is, by using reflected wave, radar sees whether there's an object. Because if no object, the pulse will not be returned. If we return, there's an object. Then you want to find out where it is, distance. The distance can be calculated using the formula. Note down, distance d equal to, or range r equal to, because most of the time they said range r, both are same, correct? In radar terminal they call range, but generally we say the distance only. R is nothing but t. T is the total travel time. Total travel time by the electromagnetic travel time by EM wave. We transmitted a pulse at t equal to 0. This is the pulse I am showing as red color pulse. A short duration pulse. Please note that the pulse width, this is called pulse width. The duration TW is called pulse width, can be, or TW can be 10, maybe 1 microsecond. It can be 1 microsecond or 10 microseconds. Generally, it will not be very big. The duration will be short duration pulse. That is transmitted. Now, this wave traveled and hit an object, and it was returned back. It was returned back. This is the return pulses. The green one is the return pulse. This is the total time taken by the pulse to travel and return back. So the time is known capital T. Now, capital T divided by 2 is the one-way travel. Time taken for, this is the total time, is the one-way travel. Multiply it by speed of electromagnetic wave, which is nothing but c. That's it. This is how radar works. Simple radar. Deducting the range or distance is done by this. What it does, it transmits a pulse of a short duration, maybe in the microsecond, but powerful pulse. In the when we talk about electromagnetic, we are talking in the power in kilowatts. Electrical power supply, so the electromagnetic power also we talk in kilowatts or watts or megawatts. Kilo means 10 power 3. We know that. Mega means 10 power 6. If I wanted to detect the object far away, my power transmission power should be higher. Higher the power, the electromagnetic wave can travel for longer distance and get reflected. Okay. Now, so this is note down the formula. Distance range of the object can be detected by sending an electromagnetic wave. When the electromagnetic hits an object in front of the radar and it is reflected back, the reflected pulse should be captured by same antenna, and the electromagnetic, the radar has electronic circuit which can measure the time traveled by this. There were capital T. Then it divided by 2, multiplied by C. C equal to speed of electromagnetic wave, speed of EM wave, electromagnetic wave, which is nothing but C equal to 3 into 10 power 8 meter per second. Have you heard this number anywhere? This 3 into 10 power 8 meter per second.
Speed of light.
Yeah. Please note that light also electromagnetic wave only. It is a radio wave only. Correct? But only thing is, in your eye, there's a retina. In the retina, small cells are there. We are called as cones and rods. The shape of the cells on your eye retina, whether it is a snake, it is a bird or animal or human, if you have eye, inside the eye, there's a lens. Lens focuses an object on your retina, where the object to image will be focused. That is called as the retina. Retina contains billions of cones and dots, cells, each measuring few micrometer height and diameter, less than that. Okay, so if I say that this is my retina, inside your eyeball, back side, maybe a small area measuring few mm. This may be 3 to 4 mm. This may be something, a small area, which is called a retina. Inside retina, it has 40 into 10 power 6 to 100 into 10 power 6 cones and rod cells. See, within that area, correct? You say that 5 into 5, 25 millimeters square, that is retina area. How much it is? This is nothing but 40 megapixels. It's a camera. Some humans have even 150, 120 megapixel also. That depends on individuals. Retina, higher the sensitivity, more clear you can see the picture. What is called spatial resolution. Small, this one also, correct? Small lines, this one also they can see. Correct? Every human doesn't have same retina. That depends upon a race, genes, your food, all this genetic, all these things. It varies something approximately from 40 megapixel, which is nothing but 40 into 10 power pixels into 2 up to 120, 150 also some people. Higher this one, you can, correct? You can see small objects also, very, very small objects also. That's why some people, you see, some people cannot see even eye of the needle, correct? Sewing needle. Some people cannot see it. They say we are not visible. But some people can see very easily because of the individual eye. That's okay. Now, why I'm telling is the light speed is in the universe, the fastest object which can travel is photon. Correct? Photon is there's a particle which called light particles. Correct? All the sources which generate light, sun, moon, star, or your electrical light, or your stove, or fire, wood, whatever burn. Correct? When heat is generated, become this one. They generate photons. The photon can travel 3 lakh kilometers per second. That's what we say light speed. In the universe, you cannot travel faster than light. It has been clearly proved by Einstein for the theory of relativity, where he talked about E equal to mc square. Correct? Energy is nothing but mc square. M is the mass. Correct? C is the speed of light. 3 into 10 power 8 meter per second. Right? So if mass is converted into energy, each gram of mass can be converted to this much joules of energy. Mass multiplies C, 3 into 10 power 8 into 3 into 10 power 8. So many joules of energy can, that's why the E equal to mc square. Here the C represents speed of light. Okay, fine. The electromagnetic waves also, radio, that means TV signal, your cell phone signal, radar signal, X-ray, light, all these things are electromagnetic waves. Electromagnetic waves can travel in this empty space also. EM waves EM can travel in empty space also. That's why light created by stars, sun, which is billion, trillion light years away, is able to come to your eyes. You are able to see these stars also, because it can travel even in the empty space where there's no gas, no atom, nothing. But another thing, waves are there. What we call a sonic wave. What is sonic wave?
Sound wave. Travels at speed of sound.
No. Sonic wave means sound wave.
Yeah.
Sonic is a Greek word. Sound is represented by sonic. Correct? That's why because sound waves are sonic wave. Okay. So sound wave, if you have to travel, what do you need?
You need a medium.
Some medium is required.
Yeah, some medium is needed. Gas, liquid, or metal. Something should vibrate. Where sound, see, when I talk, my vocal cord is moving. A muscle inside my throat is moving. What it does, while it's moving, there's air, correct? Air around my, when I open my mouth, the air goes in. That wave is compressed. When something is vibrating, the air near that will be compressed and expanded. It happens because you're pushing. Right? My vocal cord is pushing. When it moves forward, when the vocal cord goes back, there's a vacuum in there, the air goes back. The air molecules, oxygen, but inside there you have 77% nitrogen, all the gases. The gas molecules are traveling, compressed and expanded because of the movement. Okay, that is what we call as a pressure, sound pressure waves. Those waves are traveling. For traveling, what are subsequent the gas molecules as compressed waves, so that pressure wave is moving by moving the gas particles. But as it moves, the energy in the sound wave becomes lesser and absorbed by the gas molecule itself. Correct? Gas molecule absorbs that energy. So if how much energy I'm producing my vocal cord depends on that. Sound will travel 100 meter, 200 meter. We say loudness. I am able to generate higher pressure, sound pressure. My sound will travel for longer distance. If I talk slowly, my pressure is less. So the sound will travel on a few meters. For that, a media is needed. Gas, liquid, even metal also. So you tap on a metal, correct? Then another thing is speed of the sound is not fixed. What is speed of sound? Any idea? Yeah.
340 meters per second in hour, I think.
340 meters per second at 1 bar pressure. Nothing but sea level. At sea level, sea, if you go to beach, stand on the surface of the sea, touch. There it is 1 bar pressure. Correct? Already they calculated. There, if sound wave travels on sea surface, exactly on sea surface, will be 340 meters per second. Now, if I go up, the air pressure reduces. If the pressure reduces, speed reduces. Why? Pressure reduces means the density of air molecule, that means molecules, air molecule, oxygen, nitrogen molecules, the atoms are far away. Correct? Far away means the speed of the sound will reduce. When you go to space, there is no molecules at all. Even if I talk, there's nothing to compress and expand. My vocal cord is still working in space, but there's no media which can transmit my sound pressure waves, which are called as sonic waves. Not possible. That also we are using in autonomous vehicle, ultrasonic waves, ultrasonic wave sensor. We are going to see, correct? That's also used for measuring short distances. For reversing your car, backside you are putting some 5 sensors. They are ultrasonic sensor. They are also same principle. Instead of sending the light wave, we are transmitting sound waves using ultrasonic sensor. It generates sound waves. Only thing is the frequency of sound is above 20 kilohertz. We know that human ears can sense 20 hertz to 20 kilohertz, 20,000 hertz. That is the sensing range of human eardrum. If the frequency of sound wave comes lesser than 20 hertz or greater than 20, it cannot detect. It may be. So if frequency of sound wave is above 20 kilohertz, it is called ultrasonic sounds. Ultrasonic sounds generally generates sound is a signal similar to this radar from 20 to 100 kilohertz. That will be the sound signals it generates, and that will be transmitted. And if a sound goes and hit an object, and if it is reflected back, that will be sensed by same ultrasonic sound, sir. Same principle. It sends a sound signal reflected. It knows the time. Total time divided by 2 is the sound wave to travel from one way. Then multiply it by t divided by 2, multiplied by 340. If it is a sea level, this is the speed of sound. That is the distance. You can say that what is the object. That's how the ultrasonic sensors are reversing, car reversing, all those things. But sound wave cannot travel longer distance. They can travel maybe 100 meter, 200 meter, not beyond that. Generally, they use for short range, 1 to 10 meter, 20 meter distance. Okay, that we'll see later. Now, let us see, come back here. It uses electromagnetic wave. We know that what is frequency? Number of times the electromagnetic moves, because we say sinusoidal. This is called a positive peak, and this is called negative peak. Sinusoidal wave value start from 0, the increases to goes to a peak value, again decreases, reaches 0, then it comes back to a negative peak. So this is positive value, this is negative. I say negative peak, this is called positive peak. The shape is sinusoidal shape. So this is called one cycle. One positive half cycle, one negative half cycle. Together is called as one cycle. This is called periodic wave. Right. That means it repeats. This is one cycle. I say first cycle. Then same thing repeats. You can say the same positive, same amplitude. Correct? This is negative. Okay. This time, if this time is called now, I say that this is t equals 0 starting. Correct? And say this is 1 second. So what is this? 0.5 second. What is the frequency? Frequency of any waveform, periodic wave, is nothing but 1 divided by t, where t is called cycle time. This time is called as capital T, cycle time. 1 divided by cycle time is the frequency of this waveform. Otherwise, I say t equal to 1 by f. Both are same. Time, cycle time equal to 1 by frequency. If you know any one, other one you can find out. If I say that, we know that in electrical signal coming 220 volts, we say the frequency f equal to 50 hertz. How it varies? The generated joulers, correct? In power station, the electrical generator sinusoidal wave, this value of this is 0 to increases. So this is called V peak, correct? In what we say the voltage, 220 volts. We are saying 220 volts is 50 hertz AC, correct? This is called as RMS voltage. RMS means root mean square value, right? So generally they call VRMS. Generally we say V equal 220. They call it should correct technical this one. You say V substitute RMS. Root mean square value is nothing but 220 volts. Correct? We know that there is a phase and neutral. Two wires are coming. Between the phase and new, if you connect a meter, correct, voltmeter, correct, it will show 220 volts. What the value is saying is nothing but RMS voltage. The RMS voltage, if you have RMS, what is peak voltage? Peak voltage is nothing. V peak equal to whether positive or negative. It can be positive or negative. It's nothing but VRMS multiplied by root 2. So this peak value, positive peak, how much is that? 1.404 multiplied by 220. How much is that? something around 310 something. Exact number somebody can tell, calculator. Okay, that is called peak. So this value, positive peak, is nothing but in supply voltage. If you measure the peak voltage for supply, whatever 220 volts will be this much value. That is V peak. Same thing will be negative side also, because they are going positive and negative. So this is called as one cycle. This is the second cycle. This is the third cycle. Right? So like that forever, the generator is generating in power station. That's what you are getting. Right? This is voltage you are getting. If you use the oscilloscope, what is the equipment you use? You can use oscilloscope. Is an equipment you would have seen in electrical lab to see this waveform and also measure peak value, all those things. Once you know the peak value, you can calculate RMS value. VRMS equal to V peak divided by √2. You can calculate. Okay. Then we say that this 50 Hz signal. What is one cycle time for the AC voltage in your home? T equal to 1 divided by 50 seconds is nothing but 20 milliseconds. To one cycle changes, one positive and negative, the waveform is going 0 to increase and decreases within 20 millisecond time. How many times it happens within that 1 second duration? 50 times. They say 50 cycles. Right? 50 times it becomes positive, negative, positive. We say 50 Hz. Hz is the unit for measuring frequency. Right? Or number of cycles per second. F equal to 50 cycles per second or Hz. Hz. Right? The person who invented, his name is Hertz. To honor him, they gave the unit Hertz. He only first saw the waveform, all this thing, LAC. So that. Okay. Now, what I want to say, why I'm telling all this thing is, your radar can send a sinusoidal waveform or a square waveform, square pulses. It can send any of things. I told you the transmitted EM, electromagnetic waves, can be like the sinusoidal or it can be square pulses. Right? So please see that this is a periodic wave. It is a sinusoidal shape. And this is a square pulses. So that means this is one period. This is the T for the square pulse. This is the T for the sinusoidal, this one. Okay. Now, once it is a periodic, automatic frequency will be. So that is what I'm telling. The frequency of the signal, transmitted signal, can be in megahertz, gigahertz, or terahertz. What is mega? Mega equal to 10 power 6. Giga means 10 power 9. What is tera? 10 power 12. Now, if I say that my radar is generating a sinusoidal wave of 1 megahertz, right? The electromagnetic 1 megahertz. I say that 1 megahertz. Then how many cycles within come 1 second period? This is 1 second. Means 10 power 6 waveforms. This is one cycle. Like this second cycle. Within 1 second, 10 power 6 cycles. 10 lakhs times the electromagnetic goes positive and within 1 second. Right? Instead of that, if I say that 1 gigahertz, same sinusoidal wave, or it can be square also. Right? It goes to a positive, again 0. Again positive value 0. This they call frequency of the signal. If it is, I say that giga, it is 10 power 9. Tera means 10 power 12. That means 10 power 12 cycles within 1 second. That's why we call tera. Okay. We will see why there are different. Why not only? Right? There is a reason that I will, when we talk about the radar, we'll see. Anyhow, in subsequent slide. So radar can generate electromagnetic waves in megahertz, gigahertz, or terahertz. It can generate this one depending upon requirement. Right? We will see what it is later. Now, the electromagnetic waves are governed by the electromagnets are traveling in the space. Correct? That how it travels, the energy, all these things are governed by Maxwell equation. He's a German physicist. Correct? He invented this electromagnetic wave some 150, 120 years before. Correct? Recall Maxwell equation, which says that how energy is transmitted. The electromagnetic wave travels at speed of light. I know that C equal to 10 power 8 meter per second. This is the speed of light. all electromagnetic wave, including your X-ray, cell phone signal, all these things will travel, including light. Then to transmit this wave, to transmit wave, you need antenna, correct? The antenna can be most of the time, if it is a high frequency signal, it can be a parabolic antenna. So dish antenna, we call it a dish antenna, correct? It may look like this. From side view, it will look like this, correct? So this will be connected to the radar system, which generate all those things. This will be transmitting wave. We know dish antenna we are using for our this one, no? Receive our TV signals.
Yes.
Yeah. So if you go on this one, you will see the tall towers will be the telephone exchange. You will see the parabolic reflector.
Many reflectors will be attached to the towers.
Yeah, towers. So they are called parabolic antennas or parabolic reflectors. But if you are transmitting signal in gigahertz and terahertz, best thing is parabolic reflector. Okay. If a signal frequency in megahertz, it can be kilohertz also. You know the TV, your FM station or AM station, we say 720 kilohertz. Right? Chennai radio, AM, they call AM station or FM station, radio. In your car also, in home also you have radio, no? There you say. AM station can transmit signal even in the kilohertz, starting from 500 kilohertz to 30 megahertz. Correct? Hyderabad station, Delhi station, BBC, all these radios are there for last 100 years. It was invented Marconi, right? They are using for transmitting sound waves. Same thing, TV. TV station also transmitting your picture, converting to electromagnetic waves. There, they will be transmitting in megahertz. TV station frequency also will be transmission in megahertz. Similarly, in case of radio radar, they are using megahertz, gigahertz or terahertz for transmitting the signal. Okay, but generally they don't use kilohertz. If I use the kilohertz, there's a problem, right? If I use the low frequency signal, for example, kilohertz, right? We know that what a wire, a conducting wire is called antenna. A conducting wire can be an antenna. Antenna, in your car, no? You have a car, on top you have an antenna, radio antenna, right? What is that? This is nothing but a conducting wire that is connected to your radio inside your this one. Then when electromagnetic your radio, which can be AM or FM signal from the station. This is my station. It is transmitting and comes and hits the wire. It induces voltage. When EM, electromagnetic wave, cuts an antenna, a voltage is induced. A voltage is induced in antenna. Correct? This is called a receiving antenna. Generally, short form RX means receiver. This is called transmitter. This is your radio station. Radio station using a transmitting antenna. You know that. Have you seen the TV antenna and the TV station near the radio station? You will see the tall, similar to tall, maybe 100, 200 meter tall structure, like a power line section. With the center, there will be a rod, copper rod, right? 100 meter, 50 meter tall. It is connected to the radio transmitter circuit, the electronic circuit. The radio transmitter will be sending, say, 5,000 volts or 10,000 volts, correct, of the radio, this one, and the current may be 100 amps, 200 amps, or 1,000 amps also, depending on what is the power it wanted to transmit. You know, power equal to V into I, where V is the voltage, I is the current, correct? So if I am transmitting 5,000 volts, sending to antenna, transmitting antenna, and supplying, say, 100 amps current, for example, 100 amps current, 100 amps current, and say 5,000 volts. What is the power, transmitted power? Just multiply 5 lakh watts or 500 kilowatts is the transmission power. Then the signal will be traveling. The distance traveled depends upon how much is the power of your station. Correct? For example, you start from Chennai or from Pune or Bangalore. You are listening to music. You are traveling to long distance car. What happens? After traveling 150 kilometers, the station will fade. You will get signal, music will come and go. They call fading because you are moving away from this one. As you move away from this one, the wave will automatically diminish. After some distance, your car is here, the signal is already lost. How it is lost? Air as molecule, right? What molecule? Nitrogen, oxygen, carbon dioxide gases, and dust particles, moisture. All these things will absorb the electromagnetic wave energy. Here it has a maximum. Here the power was 500 kilowatt. After traveling 100 kilometer, the energy supply received by antenna becomes so weak it cannot generate a voltage. Right? The electromagnetic wave energy reduces. It will not induce voltage on your receiver. Which receiver? Your cell phone receiver or your radio receiver, whichever receiver. Signal will become so weak, it cannot receive the signal. So you say that signal is lost. Same thing happens if you come inside a building, your cell phone won't work. Why? You're building a concrete building means lot of steel rods are there, steel, inside the cable rods. They absorb the electromagnetic waves, your cell phone signal. So that's why sometimes you have to go out of building so that the electromagnet will come and hit your antenna. It should hit your antenna, not the building. Inside building, you have concrete building was the problem. Right? If it is a wooden building, a thatched building, all this thing, no issue. Because grass, wood and all don't absorb electromagnetic wave. Metals will absorb. Because the electromagnetic hits, it is converted signal to grounded. So if you are inside a concrete building, not concrete, the metal rod or steel rods inside the concrete, they absorb. So that's why you have to come out. So same thing happens. Okay. Now let us coming back here. With the antenna and optics receive the signal, converts the EMI wave. What is the antenna? Is a conducting rod. Any conducting wire or rod is an antenna. Okay. It converts electromagnetic wave hits into electrical signal. Right? We say EMF, electromagnetic force. Electromagnetic force is nothing but volt. Unit for this volts. Right? If electromagnetic hits an wire, depending upon the energy of this electromagnetic wave, a voltage is induced. What is units? Is generally volts, but it will be generally in the order of millivolts or microvolts. Microvolts or millivolts. In your cell phone, if you measure the voltage received by the cell phone signal, transmitted by the cell phone tower, it will be in the order of microvolts. So inside your cell phone, the signal is again amplified. From microvolts, it will amplify to volts, not hundreds of volts. Then it is given to speaker. That's why you're able to hear. Or inside of this one. Right? Same thing happens in radar also. Okay. The radar is called as an active sensor. We are going to see different type of sensor used in autonomous vehicle, like ultrasonic sensor, right? LiDAR sensor, radar, right? These are the sensors we are seeing. Of course, you would have heard about other type of sensors. In mechatronics, we are going to see other things. Force sensor, thermocouple, light sensor, right? Temperature sensor, pressure sensor, flow sensors. All these sensors, right, work on different principles. That we'll see mechatronics. Because there I will extensively cover about sensors for 6 to 8 hours, at least 6 to 7 hours. That is very important for the people automation, correct? Not only autonomous vehicle, even other places also. Okay, these three sensors are called as active: ultrasonic, LiDAR, radar. These three sensors are used in autonomous vehicle for detecting object, lane marking, all those things. These sensors are called active sensors. Active sensor will illuminate the surroundings or object by sending. Illuminate the surroundings or the target by sending EM or sonic or light waves. Right? The ultrasonic sensor sends sonic waves. Right? The LiDAR sends light waves. The radar sends electromagnetic waves. Correct? First they transmit. Correct? They transmit electromagnetic wave, which will go and hit the object and reflected. The reflected image is received and detected by the radar, so it finds. So that if a sensor sends some energy and receives the reflected energy, from that it is able to detect the object, measure the distance. It is called as active sensor. These three sensors, ultrasonic sensor, LIDAR, and radar, these three sensors, which is most important sensor in autonomous vehicle, are active sensors. They will send electromagnetic wave, and if it is reflected, they detect the reflected wave. Using that, they detect the object and the distance. Okay. So each one uses different type of waves. One is sound wave. Ultrasonic sensor uses sound waves. LIDAR sensor light waves. Radar sense electromagnetic waves or radio waves. So they send, and because of that, they are all called active sensors. So the radar is a active sensor. Okay. So it illuminates the surroundings, and based on the reflected this one, it is involves both transmitter receiver. Radar requires both a transmitter circuit and a receiver circuit plus an antenna. Three important things are needed. It needs a transmitter which generates electromagnetic waves and sent to the antenna. So antenna sends the object in the space. And when the sent electromagnetic reflected by any object which is nearby, that wave should be received by same antenna. Then the signal generator will be given to receiver circuit. That circuit amplifies and again used a further electron processing circuit which detects the position of the object, size of the object, shape of the object, and the distance of all these things can be done. So this is how this works. This is a key point, no doubt. Okay. Next, already told you, radar uses radio frequency signal. This is for your knowledge only. Radio frequency or RF. For various purpose, we are using different wavelengths of radio frequency signal. The radio frequency signal may be naturally produced or it can be man-made. Radio signals are produced naturally or it can be man-made. In radar, TV station, cell phone station, all these things, we are generating the electromagnetic waves and propagating, and so that received by other person and you. For communication purpose, we are using radar. But light, correct, is generated by sun, stars, right? So light also electromagnetic wave only. Again, we are generating X-rays, correct, for detecting any anomalies in the human body, or X-rays are used for detecting the anomalies in the objects also. Metal crack, all these things, building crack, all these things you can use X-rays, correct? Not only for medical purpose, we are using for detecting cracks in building, railway tracks, wherever you want, you can use X-rays. So X-rays is generated by humans in the X-ray machine, but stars also generate. There are X-ray stars are there, correct? Which generates X-rays in this, like the sun is a star. It generates visible light, infrared light, and ultraviolet, right? But if you go to, there are pulsars, correct? Quasars, magnetrons. This kind of stars generate X-rays, cosmic rays, all these things. They are all electromagnetic waves. They, correct? If you expose to cosmic ray, X-ray continuously, your cells will die. You may first they induce cancer, correct? And for continuous exposure, your cells will die, you will kill. Yeah, that's why when you go to, correct, nuclear power station, you have to put the lead coated dress, all those things to absorb the gamma rays, alpha rays released by the radioactive material, right? Similarly, again, one more advice: don't take X-ray, CT scan unnecessarily. Never do unnecessarily. Unless some the doctor say you take a CT, right? Frequent exposed to X-ray, chest X-ray, CT scan, all these things. CT machine uses X-ray only. Frequent use of this one may damage your DNA, your cells inside your DNA, all those other things. You can get cancer also. I am not saying though, if it is required, I am not a doctor. Please say that I am not a doctor. If your doctor says you have to do, you had an accident, correct? He has to do. You have something. I'm not saying don't do. I am not a doctor. Don't. The professor told I won't do. Don't later complain. I'm just telling. Correct? Unnecessary exercise sometimes is not needed. Under absolute this one, each time when you expose, you know that the X-ray, the intensity of the X-ray is controlled. Right? Each X-ray machine is certified by government. There are regulations. Right? But each time when you do, it is some. But don't do unnecessarily. I'm telling. Right? Again, it is not. I am not doctor. Later, don't complain. My professor told I don't. I won't. I don't take the except. Don't fight with doctor. Right? I am not doctor. I'm just saying. Right? Each time exposed, it can definitely, but it is little harmful. It is not to this one. I'm just saying unnecessarily don't do. Right? That's one thing. So you can see that the frequency of radio waves start from 1 hertz. 1 hertz means, for example, we think it is a sinusoidal wave. It takes one positive and negative cycle. This is one cycle, right? The total duration is 1 second, right? Positive half cycle, 0 second. This is t equals 0. It starts from 0. It increases positive. This one again 0. Gives the 1 cycle. This is 0.5 seconds. This is 1 second, right? Then what is this is t, capital T equal to 1 second, correct? What is f? F equal to 1 by t is nothing. 1 by 1 is nothing but 1 hertz, right? Radio waves generally we generate 1 hertz, sometimes even lesser also, 0.01 hertz also. For some purpose, special purpose, 0.1 hertz also. Even lower. Please don't say that because they are used in submarines. Submarines use very low frequency, less than 1 hertz also to detect other submarines, other ships. To detect this one very low frequency, right? But generally we talk in terms of 1 hertz. The maximum frequency which humans is able to find out is 10 power 23 hertz, which is called a cosmic rays. Cosmos means nothing but, right? Space. The entire universe is called cosmos, right? American, British, we all called universe, but the Russians called it cosmos. Another word. Cosmos is the space where stars, all those things are there. No, right? So in the cosmic, since these waves are generated by stars, who is generating cosmic rays? Stars, right? You have red stars, blue star, then white pulsars, correct? Neutron stars, white dwarfs, black holes, correct? Black holes don't emit this kind of this one. They absorb all the energy, but other stars generate. Cosmic generate per day big stars, which mass is millions and billion times bigger than our sun. Those stars generate this one, and they are there. So next one is gamma rays. Gamma rays also generated. Gamma rays generate when nuclear detonation happens. Nuclear bomb is detonated. It generates gamma rays. It requires high energy and high temperature, millions of degrees. That is created in all the stars, all the including sun generate this gamma rays. Right? Cosmic ray producer. The temperature 10 million degree to 20 million degree on the core of the sun. Surface it is 10,000 degree to 5,000 degree centigrade. Surface of the sun. Okay. In the core it can be 20 million degree centigrade. So there it generates all these things. Then X-rays already we know. Like this ultraviolet rays. In sunlight consists of what? Ultraviolet rays and also visible light and infrared. Correct? If why sunlight is hot? Sunlight is hot because of infrared. Sunlight consists infrared also. The maximum heat, because we are receiving ultraviolet ray, visible red, blue, green, which is a white light, if this one, and also in this 90% of heat energy is contained in ion. Sun radio, all the waveforms, red, green, blue, all this thing it generates, and the visible light when mixes become white. RGB, correct? All the words are coming together, we call white light. So use a prism, you can see that it consists of red, blue, all those things. But heat from the sun is carried by infrared light, not by the white light. White light doesn't carry heat, much heat. it is only 1 or 2%. Maximum heat is carried from the sun to the space, including sun, is by infrared waves. They contain 90% of sun heat energy. Right? Have you gone to hospital? Sometimes, if your muscles are, for example, cramp happens, all those things, they say they are allowed to give treatment, correct? Physiotherapy. They say IR, correct? So you have pain, you have fallen down, there's a swelling in your hand, correct? They use infrared light, heat. If you see that they bring near that, you won't see any visible light, but hot waves will come, you can see it. That's nothing but IR, correct? Heat can be used for reducing the swelling and relaxing your muscles. They use IR therapy. They say weekly, 3 days you come, 5 days you come, still the pain reduces. They use IR. So IR waves only consist of. Then of course we call microwaves, correct? Then your radio frequency, correct? So we talk about gigahertz. I told you gigahertz, terahertz, megahertz, kilohertz. These are all used for the cell phones, TV, AM, FM, and radar circuits. All these things use the signal whose frequency is in the order of kilohertz to terahertz, not more than that. The higher frequency signals, gamma rays, all those things, we don't, except X-ray, we don't generate much of things. Visible light we are creating, correct? Using all your light source, tube light, there's all those things we are there. These waves generally we don't, gamma rays, all those things, they are very highly harmful, including X-rays. Don't expose yourself to X-rays, cosmic rays, gamma rays, even ultraviolet rays. Ultraviolet is also not good for your eyes. You should not see the ultraviolet rays continue. Your retina will be damaged. Right? So you should be careful. Other things are okay. Less than this are not much harmful, but even the radio beyond certain energy is there, it will be harmful. That's why they say that birds are affected, eggs are, cell phone towers. Because of the bird population reducing, continuous exposure, all the birds, all insects, cell phone, they sit on cell phone towers. So because of radiation, they don't produce good eggs, correct? So no new chicks are producing. This is the reason environmental people are talking, but nobody is going to listen. We cannot live without the cell phones, right? If they say so, that the only way is you should switch off all the cell phone system itself. That's not going to happen, correct? That is another way we can be done. So now we say that this radar, I will just, so we are using these wave frequencies, correct? Terahertz to megahertz. That is 10 power 6 to 10 power 12 hertz is the frequency of the radio wave transmitted. It can be sinusoidal or square pulses in your radar. Okay. So next thing what I want to say is there are already told they send sinusoidal square pulses, which is also called modulated pulses. We'll see what it is later. Then they use the frequency range 400 megahertz to 20 gigahertz. This is the frequency of the radar, correct? They generate waveforms. Generally, they use 1 gigahertz to 17 gigahertz. This is 1 gigahertz into 17 gigahertz, especially radar used in autonomous vehicle, correct? Where the range of this is frequent generally used, right? Not meant for, these radars are used for measuring distance, something up from few meters to maybe 1 kilometer. You can detect object up to 1 kilometer distance. They use this frequency range, and they use power in the order kilowatts, right? Not in gigawatts, megawatt. They don't need. We will see why it is. There are two types of radars are very popular. One is called pulse radar. Other one is continuous wave radar, also called as Doppler radar. Continuous wave radar also called Doppler shift radar or continuous wave. This is other name. Or other one is called pulse radar. There are two types. We will see what it is. Okay. First, we will talk about pulse radar. Correct. So please take the notes, because in exam, you know, they already wrote exam. You know what is expected. Right. For example, write about pulse radar with the functional block diagram. This is called functional block diagram. We are not drawing circuit. What are internal subsystem? we take a car, you say that engine, right? If from the engine it goes to gearbox, from that it goes to differential gear, then it goes to wheels, then you have steering system, right? Then you have brakes, ABS. This is going to control the brakes. So this we call a functional block diagram. I say like that. The radar also has functional block diagram. It has one system called transmitter. What is job of this? I have written red color. You can see that the transmitter generate RF. It consists of RF oscillator. They called as the circuit which generates the sinusoidal wave, which is we are going to transmit, is generated by an RF oscillator circuit. That is part of the transmitter. Generates RF this waveform and also amplified. While generating, the amplitude of signal will be in the millivolts. Actually, the transmitter consists of two parts. One is called oscillator circuit. Then it has an amplifier circuit. Together, it is called transmitter. So here, it generates sinusoidal wave whose amplitude is in millivolts. And it should be amplified to a bigger waveform. For that, you use an amplifier. Together, it is called transmitter. Transmitter circuit generates the waveform. Transmitter, it can be sinusoidal or pulses, square pulses. Depending upon which one to use, that depends on our cost. There are so we are not going to discuss because our interest is not to design a radar, all those things. We need to understand because we are going to use it. Correct? In autonomous we are going to, so we need to understand how it works. Beyond that, we are not going to see. Radar itself, we can talk for 40 hours. Okay. So the oscillator circuit generates the waveform which is in the RF middle, then it will be amplified. It consists of that. Okay. From the amplifier, the transmitter sends this amplified, correct? So this is, you can see the signal is coming. It comes to a circuit system called duplex switch, correct? Duplex, what is the job of this? Okay, we will talk about it. As a duplex, it is connected to duplex. Similarly, we have a receiver circuit. Like a transmitter, you have receiver circuit. Receiver circuit also is connected to duplex switch. Please see that transmitter is connected to duplex switch. Similarly, the receiver also is connected to same duplex switch. Okay. Now, the duplex switch is connected to the antenna. This is the antenna. This is a parabolic antenna. Correct? We say that it is a parabolic antenna. Radar use a high frequency signal, so they use radar. Right? So parabolic reflector, which we see for our dish antenna. Correct? That is called parabolic reflector. So, what is job of antenna? It radiates from the signal coming from transmitter will be radiated like this. Correct? The dash line is nothing but electromagnetic wave. Okay. Now, the transmitter, what it supplies is electrical power, EP. Correct? What type of electrical power? A sinusoidal waveform. It has some voltage and also there's a current. That is what supply. This is the antenna is receiving electrical power with voltage and a current. So once it is supplied, automatically the antenna is made of conducting material. This also made of conducting material. The parabolic reflector also made of aluminum, some conducting metal, right? So once you give, it converts the electrical power into electromagnetic waves. This is what electromagnetic EM waves. That waves will be again, you are giving electrical voltage sinusoidal, electromagnetic also will be the same, but it becomes an electromagnetic wave. This is EM waves. This is electrical wave. Electrical wave is supplied by the transmitter to the antenna through the duplex switch. Now, once you give the electrical power, which is not the current and voltage, which is sinusoidal, it generates electromagnetic, which is also sinusoidal, but electromagnetic automatically transmits. You need not do anything. Once wave is created, the electromagnetic will start traveling from the antenna towards space. Correct? So it will be traveling like this. This is called parabolic reflector. So the signal will travel like this only, not like a cone. Right? This will travel. Now, when it travels, correct? When it travels, if there is an aircraft, for example, there is an aircraft coming, This waves and goes and hit, and it is reflected back. So this is a reflected waveform, right? This is reflected. It comes and hits same antenna. When it hits antenna, when EM wave, electromagnetic hits an antenna, automatically electrical voltage is created. Electrical voltage is induced. We call induced. The electromagnetic induced voltage, that voltage is connected to receiver. Correct? No. Now you understand one thing I want to tell, that when the wave, the voltage generated by transmitter, electromagnetic, which has to be transmitted, is to be connected to antenna, the duplex switch will be connected like this. This is switch, you can see that it will be connected like this. So the voltage from here will go to the antenna and it travels. This is what traveling outward. Once it is traveled, after some time, what will happen is the duplex switch will be connected like this. It will be disconnected from the transmitter. The antenna will be connected to, say, single antenna. Please, only one antenna. The antenna will be connected to receiver. Now, from here, received signal comes. That voltage, which is generated in millivolts or microvolts, will be connected to receiver. In the receiver, there's an amplifier. From millivolts, it amplifies to volts. That is sent to display circuit. Okay. So, we need electrical power. There's electrical power. Then another circuit is synchronized is there. I'll stop here. Next professor may be waiting. Tomorrow we will continue this.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
Tomorrow by 5 o'clock.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Give your attendance. Yes, sir. Chat message.
Yes.